Hi, today we're doing 9.3, the hyperbolas. Okay, so the standard form of the hyperbola is x minus h squared over a squared minus y minus k squared over b squared. So the x part's the positive part if it opens horizontally, like here. And it's y minus k squared over a squared minus x minus h squared over b squared if it opens vertically. Now, unlike with ellipses, and it looks a lot like ellipses except for the minus. Here a doesn't have to be bigger than b. What has to be the case if it opens horizontally, the x part's positive. If it opens vertically, the y part's positive. In either case, the foci are located c units away from the center, where, notice this is different too. C squared is a squared plus b squared. Before it was a squared minus b squared. And the vertices are located a units away from the center. So you find the center, your HK, and then it's going to go either, in this case, up A and down A, or in this case, up here to the right A and to the left A. So then what's important, let me get that picture back here. These are two examples of hyperbolas. Typically the way we're going to draw this is we'll find our center, find our vertices, and then we'll find these lines. These are not actually on the graph, but those are asymptotes. So the graph is going to approach these asymptotes as x gets large. It'll go through the vertex and go back up. So the asymptotes are found here. Description of the asymptotes of hyperbolas. The asymptote of the hyperbola, x minus h squared over a squared minus y minus k squared over b squared. So that means it opens right and left are the two lines. Watch this, y minus k, that's going to be consistent, x minus h, but it's going to be b over a. That is the number under the b part, the square root of that, over the square root of the number under the x part, positive and negative. In the second case, when it opens vertically, it's going to still be very similar, so you really should recognize that these look very similar. If it opens vertically, still y minus k is still x minus h, but it's going to be a over b, where a is the square root of what's under y. So still it's the square root of the number under the y, and it's the square root of the number under the x. So while these change their labels, it's always the number under y, number under x, square root of. That's where we get those. We make a note here. This is where it opens horizontally. And here it opens vertically. So if you want to pause that and write that down, feel free to do so. Look at these graphs. A little different than we've seen before. They go up to 10. So it's to sketch the graphs of the following hyperbolas using asymptotes as guides. Determine the coordinates of the foci in each case. So our center is going to be at negative 2, 2. Negative 2, 2. That's our center. And this is going to open vertically because the y part is positive. Now a squared is 25, so a is 5. So that means our vertices are going to be 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So located at negative 2, 7, and negative 2, negative 3. Remember, our a is 5. Our b squared is 9. So b would be 3. So if we look at the asymptotes, it's going to be y minus 2 equals square root of the number under the y is 5. Square root of the number under the x is 3 times x plus 2. So y minus 2 equals 5/3 x plus 10/3. So I'll add 2 to both sides. Y equals 5/3 x plus, that makes it 16/3. The other case, we have y minus 2 equals negative 5/3 times the quantity x plus 2. So y minus 2 equals negative 5/3 x minus 10/3. So adding 2 to both sides, y equals negative 5/3 x minus 4/3. This one and this one. So our intercept in the first case is 16/3. 16/3 is a little more than 5. It's 5 1/3. And our slope is 5/3. So it's going to go up 5 over 3. It's going to go down 5. 1, 2, 3, 4, 5. And then to the left 3. No, I messed up. It starts here. No, that's right. That's right how it was. Okay. We can do that again. Go down 5. To left 3. And then the other one intercepts at negative 4/3. There we go. So our intercept is going to go to that point. Slope's negative 5/3. So if you'll go down 5, 1, 2, 3, 4, 5. To the right 3. Or it'll go up 5. 1, 2, 3, 4, 5. Back 3, 1, 2, 3. 2, 3, 4, 5, 1, 2, 3. And it's going to approach those asymptotes. Last thing it asks us to find the foci. They're going to be c and it's away from the center. In this case, c squared equals a squared plus b squared. So c squared is going to be 25 plus 9. C squared is going to be 34. So c is going to be plus or minus the square root of 34. And that's going to be 5 point something. Let me get that value. .83. So that means we're going to go up 5, let's see, 1, 2, 3, 4, 5, right about there. That'll be at negative 2, comma, 2 plus the square root of 34. Go down 5.83, 1, 2, 3, 4, 5, right about there. That's at negative 2, comma, 2 minus the square root of 34. There you go. And there's our first hyperbola. Yay, we did it. Let's do another one. So the first one was set up in standard form. The next one is not, so we'll have to complete the square. So it's x squared minus 9y squared plus 4x plus 18y minus 14 is 0. It's going to be x squared plus 4x plus blank plus, or should I say minus 9y squared plus 18y plus blank equals negative 14 plus blank. That's x squared plus 4x plus blank minus 9 times the quantity y squared minus 2y plus blank equals negative 14 plus the first blank. I should say, should have said minus 9 times the second blank. It's the minus 9 there. Well, I'll leave that off in the first one because I hadn't factored that out. So in the first case, it's going to be a 2 here. No, sorry, half of 4 is 2, 2 squared. Half of negative 2 is negative 1, so it's negative 1 squared. So I'll have a 4 here and a 1 there, because negative 1 squared is 1. We end up with x plus 2 squared minus 9 times y minus 1 squared equals, so it's negative 14 plus 4 is negative 10 minus 9 is negative 19. Oh, that should have been positive 14, not negative. Okay, so one more time. 14 plus 4 is 18. 18 minus 9 is 9. Now we divide everything by 9 then. We have x plus 2 squared over 9 minus y minus 1 squared over 1 equals 1. So a squared is 9, so a is 3. B squared is 1, so b is 1. Our center is going to be located at negative 2, 1. Negative 2, 1. So this opens horizontally. If our A is 3, it's going to go to the right 3 and the left 3. Now, as far as our asymptotes go, we do y minus 1 equals, now the square root of 1 is 1, so that's the number under the y. 1 over the square root of 9 is 3 times x plus 2. Y minus 1 equals 1/3 x plus 2/3. Adding 1 to both sides, y equals 1/3 x plus 5/3. Let's get the other asymptote before we graph. The other one's going to be y minus 1 equals negative 1/3 times the quantity x plus 2. So y minus 1 equals negative 1/3 x minus 2/3. And if we add 1 to both sides, y equals negative 1/3 x plus 1/3. So let me circle that one. So 5/3 is the intercept. Slope is 1/3. So we're going to go down 1, back 3, 1, 2, 3, down 1, back 3, or up 1 to the right 3. Up 1 to the right 3. The other one has a y-intercept of 1/3. Negative 1/3 is the slope, so up 1. So you left 3, 1, 2, 3. Okay, or down 1 to the right 3. Okay. We'll graph this now. Curve is going to go through the vertex and follow the asymptotes. Okay. And we want to find the foci. C squared is a squared plus b squared, so c squared is 9 plus 1, c squared is 10. C is plus or minus square root of 10. And the square root of 10, to give us a decimal equivalent, would be 3.16. Just to give us a visual on this. So it's going to be 1, 2, 3, so right about there's the focus, and right about there's a focus. And they're going to be located at, where's our center, negative 2, 1? It's going to be negative 2 plus the square root of 10, comma 1, and negative 2 minus the square root of 10, comma 1. Okay, there you go. Foci, there's the graph, asymptotes, all that good stuff. Let's look at example 2. Example 2 says, find the center foci and vertices of each hyperbola that the equation describes. So we're not graphing this one. Just need to find the center, foci, and vertices. Complete the square. 4x squared minus 9y squared minus 36y equals negative or equals positive 72. So 4x squared minus 9 times the quantity y squared minus 4y plus blank equals 72 minus 9 times blank. So half of 4 is 2. 2 squared is 4. So it's 4x squared minus 9 times the quantity y minus 2 squared equals, so it's 72 minus 36. We divide by 36. We have x squared over 9 minus y minus 2 squared over 4 equals 1. So right off, our center is not so bad. It's going to be 0 for x and 2 for y. This is no h, so 0 for x. Let's see, that's our center. Foci are going to be c units away from that, so our c squared is a squared plus b squared, which in this case is just going to be 9 plus 4, or 13. So c equals plus or minus the square root of 13. So our foci are going to be located at, this opens right and left, so it's going to be 0 plus or minus the square root of 13, comma 4. And the last thing is the vertices. Well, a is equal to 9. A squared is 9, so a is 3. So our vertices are going to be located at 0 plus or minus 3, comma 2, which is going to be negative 3, 2, and 3, 2. So we have our center, we have our foci, and we have our vertices. And that's it for that problem. Okay, so we've graphed these, we found different parts of them. Now we're going to move on and to come up with the equation of them given conditions. The next two. Okay, find the equation in standard form for the hyperbola with the given properties. Foci at 1, 5 and 1, negative 1. So at 1, 5 and at 1, negative 1. Those are the foci. That means midway between that is going to be our center. So the center is the midpoint for 1, 5 and 1, negative 1. It's going to be 1 plus 1 over 2, comma, 5 plus negative 1 over 2. That's going to be 1, comma, 2. And it opens vertically, so we're looking at y minus 2 squared over something minus x minus 1 squared over something equals 1. We need these somethings. And we're also told the vertices are at 1, 3 and 1, 1. That means our A is 1. And our C is 4. So if A is 1, A squared is 1, so we're good with that. If our C squared is A squared plus B squared, and our C squared is going to be 4 squared, equals A is 1, so 1 squared plus B squared. 16 equals 1 plus B squared. B squared equals 15, so B, that's all we really need. B is going to be the square root of 15, so we'll just put 15 there. Got something wrong there. Okay, I think my issue is that C is not 4, it's 3. That would make a difference. Okay, 3 squared. So this is 9. 1 from 9 is 8, square root of 8, but all we need is the 8. And that's it. So knowing C, knowing A, we can get the B. Knowing the foci locations and the vertices, either one of these would have given us the center. And that's the equation of the hyperbola. Y minus 2 squared over 1 minus x minus 1 squared over 8 equals 1. Okay, feel free to pause that one. We're going to our last example here in this section. Okay, asymptotes of y equals plus or minus x minus 2 plus 1, and vertices are at 1, negative 1, 1, and 5, 1. This means it's opening horizontally. So our midpoint between negative 1, 1 and 5, 1, it's going to be negative 1 plus 5 over 2, 1 plus 1 over 2. That's 2, comma 1. So we're looking at something like x minus 2 squared over something minus y minus 1 squared over something equals 1. We need to find these somethings. Well, we know one of them, don't we? that's the center, my A equals 3.